Hi, welcome to Chapter 7. And now, Chapter 7 is a good complement to Chapter 6 because in Chapter 7, we're going to discuss risk and expected return, whereas in Chapter 6, we focus exclusively on risk and realized return. So, this organization allows us to focus on risk and expected return in Chapter 7, where portfolio theory, which is focused on the expected returns, is going to start to be developed and then brought over into Chapter 8 later on. Now, Chapter 7 is going to cover the basic portfolio theories, and this is going to allow us to discuss what's most important, the basic concepts of diversification, the Markowitz portfolio theory, the capital market theory, all covered within this chapter. Now, we can use these concepts throughout the remaining chapters of the course and for the project for the class. So it's very useful to know the implications of saying that stock A is highly correlated to stock C or correlated with the market. So these are things that we're going to talk about in Chapter 7. So Chapter 7 is going to serve as an introduction to portfolio theory for our class, centering on the important building blocks of the Markowitz model. So you as a student are going to learn such well-known concepts as diversification, efficient portfolios, portfolio risk, covariance, and others. And I'm going to talk a little bit about beta. So the first part of the chapter, we're going to discuss estimation of individual security risk and return, and which provides a basis of considering portfolio risk and return in each section. So it begins with a discussion of uncertainty, and we're going to develop that to a concept of probability distributions. So the importance of calculating the expected return, I'm going to go over that. And it's going to be presented as an equation, and we utilize standard deviation, something that when we get to the spreadsheet aspect of this lecture, I'll go over in the spreadsheet. So you'll see the formulas displayed during the presentation, but I'll use the spreadsheet to show you how to calculate some of the more important calculations. So then chapter 7, I'm going to continue into the Markowitz model, along with the standard dimensions of efficient portfolios, inputs that would be needed to calculate those results, and we're going to look at risk and expected return in a portfolio, how a lot of talk about the portfolio risk. And we want to show like a weighted average of individual securities within a portfolio and how it leads to analyzing risk of a portfolio. So basically, we want to look at what are the risks of the individual stocks, and then when we put these stocks into a portfolio, how do these risks work with each other? And this is where independent returns, random diversification, and Markowitz diversification come into play. Now, the correlation coefficients and covariances will be mentioned and talked about during this class. Calculation of portfolio risk will be, explained in a couple of different ways. But what we're looking to is get us prepared. So when we talk about efficient portfolios, then that's going to transition more nicely into Chapter 8, which is the next chapter coming up. Okay. So let's get right into Chapter 7 here. So when you make an investment, it's going to involve a certain amount of uncertainty. You're not going to get a definite answer of 100% of what the returns will be. So we need to focus as best we can on expected returns. Estimates, which are going to be estimates of future return when we manage or consider risk. So investors tend to be, especially in a bull market, a little bit overly optimistic about expected returns. So what they perceive their expected return to be and what the actual return is going to be are often quite different. Now, as an investor, you want to reduce risk without affecting your overall return. So you want to you basically want to lower risks and increase returns. And if you can increase returns, it's just good enough to lower risks. And if you build a portfolio, that's an easy way to lower the risks of investing using diversification as a concept there. Now, calculating the average return or the variance of return. These are two basic calculations for calculating variance of return, and these are things that you probably learn in high school or in undergraduate classes. Very basic stuff here, but I'll show you some of these calculations when we get to a spreadsheet portion of today's lecture. Now, calculating expected return or variances of return, we're going to work with these formulas where P is going to equal the probability, S would be the state, and R equals returns of the state S, which I think of as a stock. Okay, so uncertainty. And you can see in the course of this year, there's been a lot of uncertainty. And, so risk is really this uncertainty that your expected returns may not actually happen. So as we talked about last chapter, we discussed certain risks involved in investing and how they can interfere with your return. So we could use probabilities. So if we think of return as a distribution and we can incorporate probability weighted outcomes, then we can get we can assign each possible outcome to create a distribution of possibilities. So this would be a guide to look at expected future returns and the likelihood of them occurring. And the distributions can be discrete or continuous. Now, here is a basic formula for expected return for an asset, which we'll call I. So the weighted average of all the possible returns will be included in this probability distribution. And what we're going to call the outcome of these probability occurrences is P to the S. So we can refer to the expected return formula when we calculate this. And again, if you're not very versed in reading mathematical formulas and interpreting them into action, I'll show you how to do that in the spreadsheet in a little bit. Okay, so calculating risk. So we're going to use a statistical mathematical concept called standard deviation to quantify and measure the risk of our portfolios or our stocks. So this will create a dispersion around the mean and the variance of returns which will be explained as a percentage squared. So the standard deviation of returns, which is going to be the square root of the variance, and that's what this is really. This is the variance, and to find the square root of the variance, we get the standard deviation. Now, in the modern portfolio theory, so this is basically talking about at some point somebody sat down and thought about diversification and portfolio and risk and return. So this is a framework for building a portfolio. And the framework incorporates risk and expected returns. And financial managers of all sorts will use this modern portfolio theory to help quantify the benefits of certain different models of diversification. And we're going to look at things as far as correlations in the securities that determine the risk. So we want to see an asset with an individual high volatility may actually have a low risk because of the higher level of returns. Now, a weighted average of individual securities' expected returns is something that we could use to kind of make an expected portfolio return by calculating the weighted average of the individual securities within the portfolio. And that's what this basic formula represents here. So let's talk about portfolio risk. So we understand that even just because you group stocks together in a portfolio doesn't mean it eliminates all risk. So we could use the variance or standard deviation of the portfolio's returns to sort of measure this risk. So a portfolio variance, of course, is going to be impacted by two key considerations: the variance of returns of the individual assets in a portfolio, and then the co-movement of these returns of the individual assets within the portfolio. So if you build a portfolio of just oil companies, they're going to have a pretty consistent or positive correlation coefficient for the similarity of their returns. So building a portfolio of companies in the same industry is going to have less of a protecting effect of diversification than selecting various companies in various industries into a portfolio. Again, a basic concept. Now, the portfolio risk is not a weighted average of the individual security risks. So the risk of an individual security is not always a crucial consideration. Diversification is what we want to focus on, and that almost always is going to lower risk, some cases more than others. So an asset with a high standard deviation may add little to the portfolio's risk if it's combined in the right way with other assets. So it's really all about the mix. Now, risk reduction, of course, is what we want to achieve in a portfolio. We want the risks of the portfolio to minimize while maintaining or increasing their return. So market risk is going to affect all firms, something we talked about in Chapter 6. And we can't diversify away from that risk. So it's systematic. It's part of the system. And in the previous chapter, we gave examples like interest rate, inflation, that are going to affect the whole market. So with a larger number of securities, the smaller the exposure to any particular risk. So the more stocks you have in your portfolio, the smaller the non-systematic or the diversifiable risks will be. Okay, so let's talk about random diversification. So diversifying without really analyzing or thinking about how a security's returns are related to each other would be this random diversification. So the marginal risk reduction gets smaller as securities are added to this random portfolio. Now, so the benefit is not optimal. So the risk reduction can kick in as securities are added, but it takes a larger number of securities to eliminate the majority of risk. So that's just sort of a random. It's better if it's more engineered or tailored. If we look at correlation, so we could look at correlation is really how two objects move together. So if you have a 1 is perfectly positive correlation, think of two people are handcuffed together. They're always going to be in the same location. Now, a -1, perfectly negative correlation, would be two people on the opposite sides of the world who don't travel. So they're never going to be in the same location at the same time. 0 is no tendency either way. We can't really predict the movements of these two assets. It's just no relation. So correlation is really looking at, is if stock A, B, and C have a 1 perfect positive correlation, there's no real, there's less benefit in grouping them together in a portfolio than assets with smaller positive correlations. So here we can look at correlation and portfolio risk, where we're looking at expected returns this way and standard deviation this way. So as the standard deviation increases, so does the risk of the portfolio. And if you look at if P is going to equal 1 versus P equal -1, we can kind of build a frontier here. And it really is just expressing how it depends on how the two assets are correlated. Now let's take example of a couple different stocks. So let's look at stock H-Tech, which they call, and this would be the return of H-Tech, pretty volatile. Then if we look at Giffen, this is the return on Giffen. So if we build a portfolio of equal parts of Giffen and high tech, then that smooths out the average return, the expected return, because adding those two companies together, you're really diversifying the highs and lows of their returns and losses. So the two companies together, by and large, are going to have positive returns more consistently because of the nature, how they're not really correlated as far as their returns are the correlation is almost opposite. Not completely -1, but it's small enough correlation that they complement each other well in a portfolio to reduce risk. So diversification, remember, if you diversify too much, you mitigate your return. So diversification pays when there's a big trade, a small amount, just the right amount of diversification to trade off the maximum amount of risk. So with a perfectly positive correlation, there's no diversification benefit. So that would be, owning 2 or 3 companies in the oil industry. Is really what affects, if oil prices are going to affect all these companies pretty much equally. So there's no real benefit, since they're positively correlated, to put them in a portfolio. With negatively correlated, expected returns can be more assured. But if they are perfectly negative, if one company is going to make a 10% return, the other company will make a 10% loss. So you do eliminate your risk, but you also eliminate all your return. So you typically don't want a portfolio with a correlation of 1 or -1. You want something smaller than 1, but larger than -1. And zero correlation, you can get significant risk reduction with the zero correlation, where stocks are not really correlated with each other, and but it cannot eliminate all risk. So we're looking for zero correlation. It's not going to eliminate all risk. So negatively correlated or low positively correlated is more ideal in minimizing risk. So a hedge is typically more of a negative correlation, closer to 1 would be a hedge, where you're trying to protect your position with a opposite second position, sort of like getting a put contract in the stock while you're owning the stock. Okay, so calculating a portfolio risk. So there are 3 inputs to this calculation. We have variance, covariance of each between pairs of securities, and portfolio weight of each security. So the goal is to determine the maximum variance combination for a given level of expected returns. Basically saying, what's the best combination? So the lower the correlation covariance between securities, the better. That's sort of a generalization that we can claim. Also, the number of securities that we increase, the number of covariances grow quickly as we add numbers to the portfolio. So the importance of this covariance relationship is going to increase as well, and the importance of each individual security risk is going to decrease as we add more stocks to the portfolio, which is basic common sense. Now, if we look at the Markowitz full covariance model, this is going to require covariance between all returns of securities in order to calculate a portfolio variance. So they suggest, Markowitz, who created this theory, suggests that using an index to which all securities are related would be a good way of getting this full covariance model. Okay, so that's the end of the basic lecture for Chapter 17. Let's move into the spreadsheet, where I could show you some of the calculations that we were talking about here. So let's start with, calculating, how do you calculate the total probability? So here we have the possible returns for 5 stocks. So we're looking at these 5 stocks. And we have, and these are, we're putting it, these are really 1%, 7%, 8%, 10%, 15%, but we're keeping them as whole numbers, multiplying by 100 to make these calculations easier. And this is the probability of occurrence for these returns. So the likelihood, so the total probability, we would actually find the sum of this. So I could just go equals sum, and then the sum should be 1, or should be expressed as 100%. Now in column 2, what I'm doing here is I'm taking column 3 here. I'm taking 1 multiplied by 2. So 1 times 0.2 is 0.2 here, as you can see in the formula up here. So to get the expected return, I just need to find the sum. So let me just move this over here. And it's not expressed as a percentage. It's just going to be a number. So this would be the expected return. And this, I lost my message here because I copied that formula over. So this would be the expected return. All right. Let me just get that note out of the way. Okay, so column 4, we're going to take, this is r to the I minus the expected return. So what we're going to see here, what is this r to the I? And that's a possible return. So I just inserted the little notation here. So for column 4, what we're going to do is we're going to say r to the I minus the expected return. And I'm going to make this a little bit easier, I'm going to put a $sign in front of the C and in front of the 10 so I can drag this down. Okay, so then the next column here, what is that? 0. I didn't like that dash, I changed it to 0. So in column 5, we should just take 4 times 4, basically. We're going to square the number, which is good because it takes away the negatives in the formula. So we won't have any negatives to worry about once we square this. All right. Start over. Okay, so that's our square, 7, negative 7 times negative 7. Pull this down, and all right. So the last column 6, we're going to take basically the probability in 2, and we're going to multiply it by the result in 5. So we see this particular result here is 5, and multiply it by the PR, which is probability. So I should probably put PRI here. So you know that that's the variable. And let me do that at the front. And then if I have this I want to subscript it. I'm just going to format cells, put a subscript on that little I, so we get the same characteristics. Okay, so then this makes more sense, and then we're going to say 2 times 5. Okay, and I'll just pull this down, and now if I find the sum of this column, so the number format, I find the sum of this column, and there is, because this is truncated here, I'm missing my summation key, so I'll have to go with the formula. Okay, so this would be the variance of return. This is the little notation here. It's the variance return. Now we're going to calculate the standard deviation, which is basically the square root of this. So I'm going to use the square root function. Click on that, enter this cell, close parentheses, and this would be the standard deviation. move that down a little bit. Okay. And this is the standard deviation here. Okay, so that's how we calculate. So this would be the variance and the standard deviation, the expected return. So that's how you calculate those variables. Now you can practice it with the second example here on your own and see if you, and then you can check. I have an answer key in this handout that you can check to see if you got it right. Let's move over to some concepts in the modern portfolio theory. So here, let's talk about, let's see here. Okay, so let's calculate a portfolio return. So if we have 4 stocks here in a portfolio, so we have 4 stocks here in a portfolio, and we need to find a percentage of the investment. We have the total portfolio here. So to calculate a percentage, how much, basically it's saying how much is 5,000 into 20,000. So if I just go 5,000 divided by 20,000, I get that percentage of the investment. So it's 25% of my total. If I lock down cell B9 with a couple of dollar signs, then I can get all the percentages, and together they should equal 100%. Now, so now we have the investment, we have the return, and we want to calculate the portfolio return. Okay, so if we want to calculate the portfolio return, we want to take the what we'd call the weight times the rate, or in this case, we can take the we'll call it investment percentage, and we multiply that by the return. Okay, so that's basically saying investment percentage times the return, and that gives us, copy this down, and then we're going to find the summation of these 4 returns, and we've calculated the portfolio return. Okay, so I'm going to, why is there no box on this cell? Let's fix that. Okay. All right, so that is, you can try the second example and check your work in the answer key for calculating a portfolio return. Let's move into calculating beta. So let's just talk about beta, because beta is a good measure of risk, and beta is a good measure, but beta really basically is measuring is the beta coefficient is measuring the coefficient, or basically how closely, so like a coefficient variation of the stock in relationship to the stock market. So if we have a beta of 2.25, the stock price is 25, the market return is 10%, what would be the new stock price? So if the market, so what we're going to do is let's take put the parentheses, the beta times, what is the beta times the return? But I think what we're going to do is let's start with the stock price, and we're going to multiply that by 1 plus beta times the return. And that gives us the new stock price. So what we're basically saying is if the stock is going to be increased by 2.25 of the market, that's $5.63. Add that back to $25, and that's where you get your $30.63. So this is just a way to kind of look at what relationship, if these are 4 different stocks in a portfolio, they all have different betas, they have different stock prices, and if relating them to different markets, this would be what the new stock prices would be if the beta coefficient was correct in predicting the movement of the stock price relationship to the market. Okay, and then if we have a portfolio and we have different betas in the portfolio, we want to calculate the beta of the portfolio. This is a similar concept. And I know that beta isn't explicitly covered in chapter 7, although beta coefficient is an offshoot of, when we're looking at coefficiencies, beta coefficient is really the model we're using with stocks. So that's why I included it in this handout here. So if we take the total here, again, we take actually the individual stock divided by the total, we get a percentage of the investment. So 6,500 is 32% of 20,000. And I'm going to put, again, dollar signs here. And these create an absolute position so I can just drag it down. And again, here, I'm going to take, just like we did with the portfolio, the investment percentage times the beta to create a weighted beta. And then if I add them together, I will get a portfolio beta. And this would be the portfolio beta. So you can see that we have different betas in the portfolio, but this would be the overall beta of the portfolio. Okay, so this just covered some of the basic mathematical calculations within the chapter here, just to give you an idea. And you can try these out in your own Excel and then refer to the answer key if you want to see how I answered them. Okay, that's it for chapter 7. Thank you for spending this time with me. And at this point, I think you should go and read chapter 7, think it over a little bit. And I'll look forward to talking with you when I review chapter 8. Thanks.